Alright, so in this video we are dealing with section 7.3 of chapter 7 and that subset of reaction types, which is the oxidation reduction reactions. So we talked about it a little bit about oxidation. Basically, oxidation is when like for example the iron metal reacted with oxygen, or any metal like the magnesium, the combination reaction where things were getting oxidized from the oxygen in the air. So that's a oxidation reaction. All right. Now the way oxidation reactions happen is there is a process called as reduction that happens at the same time. So while one reactant is getting oxidized, the other reactant is getting reduced. All right, so they occur in tandem. So rusting of iron is a redox reaction. Okay. So first we have to identify what the term oxidation means and what the term reduction is. All right, so this is a redox. So the short form of this oxidation reduction reaction is redox for short, right? So in an oxidation reduction reaction, there are lots of oxidation reduction reactions, all right? It could be like the formation of the combustion reaction is kind of an oxidation reduction reaction in some sense, and a lot of energy is generated. Now when food gets digested, that's a redox reaction, and again the breakdown of food, we harness a lot of energy. The electrical energy generated in batteries is from redox reaction. So again, here you have a redox reaction, an oxidation reduction reaction, where iron is getting oxidized and oxygen is getting reduced. So one reactant is getting oxidized, the other reactant is getting reduced. All right, an oxidation reduction reaction is the best way to define it is using this acronym or this mnemonic rather, OIL-RIG. Oxidation is loss of electrons and reduction is gain of electrons. So when electrons are lost, that means electrons are transferred from one reactant to another. That's oxidation, because reactant A is losing electrons, whereas reactant B is grabbing those electrons. So reactant A is getting oxidized because of the loss of electrons, whereas reactant B is gaining electrons, which is termed as reduction. Okay, so that is the best definition for oxidation and reduction. All right, so here you can see the formation of the copper 2 oxide is a redox reaction. So copper from that statue, the copper metal, what happens is it is reacting with oxygen from the air and forming copper 2 oxide. So the copper metal, any element in its elemental state doesn't have any charge. It's absolutely neutral, no charge. Now, what is happening to the copper when it's losing electrons? For every electron lost, the charge goes up by 1, right? So that each copper is losing 2 electrons. So the 2 coppers are losing a total of 4 electrons, all right? So remember, each time an electron is lost, that atom is going to increase in charge by 1, all right? So each copper has a charge of 2 plus, because each of them have lost 2 electrons. So because there are 2 of them, that's 2 times 2, so 4 electrons are lost total. Now the oxygen, which is also in its elemental state, is again zero charge. So it grabs the electrons, all right? And there are two of these oxygens. So each electron taken up means it brings its negative charge with it, all right? So each oxygen it gains two electrons, and so each oxygen will have a 2 negative charge. And so 2 times 2, that's a total of -4, all right? So the 4 electrons get cancelled out, and when you when these copper ions and oxygen oxide ions come together, they form the neutral compound copper 2 oxide, right? So that's the final balanced equation. So here you have a redox reaction, an oxidation reduction reaction of zinc and copper sulfate. Now copper 2 sulfate fully dissolves into water. It is soluble. So the copper 2 plus and the sulfate 2 negative ions, they separate out, all right? And then you put a piece of zinc in there, and what happens? That zinc is taking the place of copper, okay? So zinc in its elemental state, it has 0 charge, whereas the copper in copper 2 sulfate has a 2 plus charge. It's a copper ion, right? Copper 2 ion in solution. So the zinc now, what it does is it loses 2 electrons to that copper, all right? So each time an electron is lost, that atom is gaining a positive charge. So 2 electrons lost means that the zinc is going from 0 charge, 0 oxidation state, to a 2 plus oxidation state. Whereas the copper, which is then grabbing those 2 electrons, is going from a 2 plus oxidation state to a 0 oxidation state, okay? So zinc has lost electrons, it is getting oxidized. The copper is taking up those electrons, and it has got reduced, okay? So zinc is oxidized to zinc 2 plus, and the copper 2 plus is reduced to copper. It's going from 2 plus to 0, all right? So anytime the charge goes up, that's an oxidation. Charge comes down, that's a reduction. All right, so identify each of the following as oxidation or reduction. All right, so it's going from 0, elemental state, anything in the solid, that's 0, and 4 plus, and it's showing that on the product side there is a loss. Electrons are coming out, all right? So this is an oxidation. Now you're going from a +3 to a +2, and the electrons are on the reactant side, so it's gaining the electron. Each time an electron is taken up, the charge comes down by 1, and so it's Fe2 plus on the other side. This is a reduction. Cl2 gas, anything in its elemental form has a 0 oxidation state, all right? So each of the chlorines is grabbing an electron, so each chlorine is going from 0 to 1 negative, therefore, and this electrons are on the reactant side, so that's a reduction. So in this particular reaction, the UV light initiates this redox or the oxidation reduction reaction between silver and the chloride ion. So silver is +1, all right? So from +1, it has gone to 0, all right? Because you don't see any charge here. And then from a negative, it has gone to 0, all right? So from +1, it's gone to 0, it's come down. That means that is getting reduced. From negative, it's going to 0, so it's going upward. That is getting oxidized, all right? So the Cl minus is getting oxidized, and the Ag plus is getting reduced. All right? So oxidation, loss of electrons. Sometimes, especially for biomolecules in when biochemical reactions, addition of oxygen is considered to be oxidation, or loss of hydrogen, especially when the enzymatic reactions, loss of hydrogen is considered to be oxidation. So reduction is gaining those electrons or losing oxygen, or gain of hydrogen is considered to be reduction. So remember these definitions. Loss of hydrogen is oxidation, gain of hydrogen is reduction. So here in a biomolecule, in a biological molecule, there are two hydrogens here, okay? Now what happens to those two hydrogens in the biological molecule? They are lost, okay? So that loss of hydrogen is an oxidation. So those hydrogens are getting taken up by this coenzyme, all right? So this coenzyme is FAD. It takes up those two hydrogens. That means it's gaining hydrogens. It's getting reduced, okay? So FAD, the flavin adenine dinucleotide, is reduced to FADH2, and the biomolecule is oxidized. Okay, redox in methanol, right? So many of these redox reactions, especially the biochemical ones, involve these transfers of hydrogen atoms. At the same time, electrons are also getting moved around, all right? So methyl alcohol, methanol, is poisonous, all right? So what happens is it starts losing some of its hydrogen, and when that happens, it is getting oxidized to a substance called as formaldehyde. Now that formaldehyde is gaining oxygens, which is also an oxidation, and forming formic acid, which is gaining additional oxygens, and then breaking down further into carbon dioxide and water. So these intermediate products, as they're called, because the reaction doesn't end here. Formaldehyde becomes formic acid, and then formic acid finally breaks down into harmless substances like carbon dioxide and water. So these are very toxic, the formaldehyde, formic acid, all right? And they can interfere with the cell function, and in extreme cases lead to death. All right. So the definition of oxidation and reduction depends on that reaction. The best definition is the loss of electrons. But as we saw in biochemical reactions, it could be addition of oxygen or loss of hydrogen. All right. Again, reduction is gain of electrons, best definition, but sometimes loss of oxygen or gain of hydrogen, as you saw in biomolecules, is also reduction. All right, we will stop here.